have something called a do loop. We don't have that either, but you can simulate a do loop by using a while true loop. And I'll show you what I mean. I don't have to type this in. After all, it doesn't work. In those languages, you do something like this. Do something while, case, right? Or while condition, like that. You can mirror that by doing this. While true, repeat this loop, except you wouldn't use that, right? Except we're talking about Python. Instead, you tab over, do something, and then if not condition, if that condition is false, then you're going to break, like that. That's how you bail out of a loop, is with a break statement, if you're doing a while true. If you have a while true, it's going to be an infinite loop unless there's a break or a return statement to kick you out of it. This is called a post-test loop because a test doesn't happen until the end. The same is effectively true here. The test doesn't happen until the end of the loop. Right? We could put a end while comment here to show that that's the end of the loop. I'm going to go ahead and do a demo of that because we didn't use while loops. Excuse me, we didn't do break statements in our last loop. We did a lot of for loops. For loops are pretty awesome, but we also need to understand the break keyword. I believe we're on F. And by the way, I think I sent out a message. Was it to y'all saying that there was going to be a video to watch? Maybe it was the C++ class.
I never saw it.
Yeah, I don't remember that.
Okay, well, I didn't make y'all watch it, so.
Okay, yeah. Comes down.
And by the way, if I get a phone call, I'm going to be incredibly rude and take it because I've been trying to get a hold of my family's physician, the one at the hospital, for about 3 days. And if they just happen to call at night, I'm going to have to rudely rush out of here and take it. And I apologize for that. Alrighty, so if we have something like this, you want to ask somebody for some input, and then you want to do some processing based on it, right? Num is equal to input, parentheses, well, let's turn it into a float at the very same time. Float, parentheses, input, parentheses, quote, enter a number, or -1 to quit. End quote, and then 2 close parentheses. Close, close. Now we're going to do while num not equal to -1 because that's the sentry value. That's the sentinel value. It's a value that'll kick you out of the loop. Then do something with 1, right? Parentheses, quote, do something with, end quote, comma, num. And then we better get the input again. I'm just going to copy that line and paste it. And then I'm going to add a comment that's end while. All right, now when I run it, it's going to ask me for the input the first time, right? And as long as that input is not equal to -1, it's going to enter the block of code and it's going to do something with it, write it, add it to something, or do some kind of lookup or whatever. And then it's going to ask for the input again. And if they type in another value, it's going to come back up and check it, as long as they didn't type in -1, and it's going to repeat the block of code. But if they type in a -1, then when they get back up here, when the computer's execution hits back up here, the -1 is no longer not equal to -1, and it's going to fall out. Fall out of the loop and do whatever's next. And just make sure that works. Enter a number, 100, 200, 300, -1. All right, that's working. I don't particularly like this structure. of setting up loops. And I'm pleased that the book shows what I'm about to do as an alternative. Most computer science books don't show what I'm about to show you as an alternative, which is a while true loop. And I greatly appreciate that this one does, because it makes me feel like I'm not crazy for preferring the other one. So I guess technically computer scientists would frown on about what I'm going to do next. Why do I like what I'm going to do next? This one has duplicate code. We ask for the input there, and then we ask for the input there again. And to me, anytime you're cutting and pasting code and it appears in more than one place, it's not great. Right? If I made a mistake in here, like if I converted that into an int, and I needed to convert that into an int as well, I might forget. I might change only one of them. It looks real easy, right? But what if you had 100 lines of code, right? Like that. It'd be easy to change this one to whatever it was supposed to be and forget to change this one. So that first input is known as a priming read or priming input, like you're priming your pump to get, some stuff going on. Here's how I would prefer to structure it. While true, capital T, colon, let's get our input. Heck, let's just copy that statement again, right? I'm going to copy that entire line and paste it and indent it properly. And then, as long as it's not, or if it is equal to a -1, I'm going to break because they're done. If they typed in a -1, if num equals -1, colon, break. Break out of the loop. Else we're going to do something with it. Technically, I don't even need the word else here, but I think that it makes kind of the logic a little bit easier to follow. So I'm going to go ahead and put an else there. And then we're going to do something with num. So again, I'm going to just copy a line of text and paste it and indent it properly. Like that. All right, enter a number. This is the first loop. When I finally type in a -1, it goes to the second loop. Now we can't really tell, right? We didn't put any distinguishing characteristics between those print statements. But you get the idea. And then I can enter a number, and then when I type in a -1, it quits the second loop. Maybe I should have put, some way of distinguishing it, like enter another number or something like that. Or, loop 2, colon, enter a number, right? Some way to distinguish it when I run it. We can see both one happening and then the other. All right. Why do I prefer that one? Because the input statement only happens once, right? It's easy to change it. It's easy to change the input statement. This is just the way that my mind works, and I'm thankful that the book shows it to us. We ask for the input, and if they type in the kill command, we bail, right? We do a break. What does break do? It jumps to the first unindented statement after the while. So like, if I put print done there. Break is going to cause it to skip everything in the while loop and run down and print done. And we'll see break again. Not like you have to totally burn it into your brain the very first time you see it. However, if you've seen it in Java or C++ or whatever, then yeah, it's going to already be in your brain. Anybody have typos that you wish I would lay my eyes upon? Nope. Yes? All right, let me come look. So a for statement, a loop, I don't know where I got the word for, I don't see it there. A loop repeats an action. Essentially, there's two kinds of loops in this language. While loop, and then there's for loop. You use for loops for counters and lists. You use a while loop if you want to repeat until a certain condition is no longer true. So I'm going to call that an indefinite loop, right? while x is less than 10, or while, c is not equal to true, or something like that. And these are definite lists because they're definite loops, because they're supposed to count 1, 2, 3, 4, 5, or print out a list. Now this is an indefinite loop, right? We don't know how many times it's going to execute. Now honestly, there's nothing you can write with a for loop that you can't write with a while loop, but the syntax is a lot cleaner. So if you can use a for loop, you're going to want to do that. If you can't, then that's fine, right? It is a while loop. Basically, you're going to use a for loop if you ever see anything counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10, 20, 30, 40, whatever. Or it's stepping through a list. Let's take a look at what stepping through a list looks like. I'm going to declare a list, and it's just going to be capital L because that's easy to type. And what am I going to put in it? I don't know. 3 words. Red. So that's a square brace. L equals square bracket, square brace, whatever we want to call it, quote, and then the word red, end quote, comma. You don't have to space it out like I do. Green, end quote, comma, blue, end quote. Alrighty, now we're going to print it out. Some languages would call this a for each loop. In this loop, I've never come up with a good name for it because it uses the keyword in rather than each, but if I say foreign loop, it sounds like, it's a loop from France. So for E, short for element, in L, that's the word in, colon, print parentheses E. So we've defined a list, we've defined a sequence of values, and we print them out with a for in loop.
Does the E always have to be there, or are there different?
You can use any word you want to there, right? I could have called this Luke, as long as I use the same one there, right? This is a variable that gets filled in first with the word red, and then with the word green, and then with the word blue, or whatever is stored in L. The first one goes into it, and then the second one goes into it, and then the third one goes into it. Does that make sense? Yeah. Last time we used for range loops, I believe. For x in range, and I'm going to count from 1 to 5, so I better make it 1, 6. And I want to skip by ones, so I'm going to put that comma 1 there, although it's not strictly necessary. If you leave that out, it'll default to 1 anyways, just to remind ourselves that we could skip by 2s or 3s or whatever. Parentheses, colon, and I'm going to add a note, as always, saying that this goes 1 to 5, just because 6, 5's a little bit obscure. And then I'm going to print out x. And we get into that annoying state where every single time we run it, we have to type in that input. We may wind up commenting that code out. So it printed red, green, and blue, and it printed 1, 2, 3, 4, 5 as requested. And I'm going to do that. I'm going to come all the way up here to the very top of my program where it says num equals float. I'm just going to comment it all out so we don't have to keep answering those questions each time. You don't have to do that if you like answering them. But I'm putting 3 double quotes there. And I'm going to scroll down to right above these comments about while loops. And I'm going to put 3 more quotes there. And then run it and make sure we didn't break it. Yeah. There's also a comment out function up in edit. Like if I wanted to, I could highlight all that. Don't do this. Edit, highlight everything and do comment. Oh, excuse me, it's under format. Format, comment out region. It just put 2 hash symbols in front of everything. And then later on, if I decide I want that code inside it, I can choose format uncomment. That'd have been another way of doing it than doing the triple hash. Excuse me, the triple quotes. All right. Now I said, and I will reiterate, There's no for loop you can't write with a while loop. I'm going to rewrite that for loop to be a while loop, and then I'm going to hit the PowerPoints again. But that means that I have to initialize my counter before I go into the loop. So x equals 1, because that's where I want it to go. While x is less than 6. Now normally I'd make it x less than or equal to 5, but they mean the same thing, right? So I'm making the syntax match this one exactly. That's why I put less than 6 here, because that's how the range statement works. Normally I'd put x less than or equal to 5 because that's the way my brain works. I want to count to 5, less than or equal to 5. Now print out x again. And if I do nothing else, I'm going to go ahead and put an end while comment here. If I do nothing else, there's a problem with this code. It's an infinite loop. That's one reason I like for loops better. I never get to infinite loops. What did I do wrong?
You didn't. X doesn't change.
Right, x never changes, and if x, and you're right, I could have used a break. Here's what I could have done. No, that's not true. A break wouldn't have worked. A break would have just printed out one number, and that's not what I wanted it to do. Instead, x plus equals 1. If you don't change your loop control variable, then it never can break out, right? That's why while true is useful. It's a shorthand way of saying, okay, run forever until you hit a break statement. But this one, we're not doing a break statement. We actually want to iterate a counter. So this code and this code do the exact same thing. And if I delete this comment and then ask you to compare that code and that code, you get to pick which one you like better. I like that one. It's only 2 lines of code. You get to see right off the bat how much it's increasing by. You know, you get to see the limits. The header tells you everything you need to know about the loop. And here that's kind of all mixed up. The starting values on one line, the conditions on another, the updates on another. You might forget the update like I did. Up to you. Anybody have syntax errors that you wish would go away? Nope. So a loop that counts through a range of numbers is a perfect use for a for loop. Now these slides are the worst slides in the world. You have to comment the inner contents of a for loop. If you want to specify a lower bound of your for statement, you put it there. This one would have printed out 0, 1, 2, and 3, except that they're calculating a product, right? They're calculating a factorial. Here they're starting at 1. Wait. Okay. Since this one is counting 0, 1, and 2, and 3, if you had multiplied it by 0, the answer would always be 0, right? Because 0 times 1 times 2 times 3, it doesn't matter if you multiply it by a million, it's always going to equal 0. So to fix that, they added 1 to count before they multiplied it. That's kind of obscure to me. I would have started the counter at 1 and then done it like that. We have seen this syntax plenty of times now. The assignment symbol can be combined with an arithmetic in order to do the same thing as a equals a plus 3. A plus equals 3, a equals a plus 3. A star equals 3 is the same as a equals a star 3, right? If you're going to add, concatenate something to the string s, s plus equals there is the same thing as s equals s plus there. So, this is just pointing out that if we want to count from 1 to 4 and we slap in 1 to 4 there, it's only going to go 1 to 3. This one has to be one pass. This one has to be the condition that rejects the loop. This is new stuff, correct? Okay. So range returns a list. No, it doesn't. That's a lie. But it's close to being the truth. Why do I say it's a lie? Watch what happens if I come up here. If I do L equals range 1, comma 10, and then I print L, it doesn't print 1, 2, 3, 4, 5, 6, 7, 8, 9. So it does not return a list, but you can turn it into a list like this. L is equal to list, parentheses, range, parentheses, 1, comma 10. And since I have 2 opening parentheses, I need 2 close. And now when I print L, there, right? Normally, are you going to do this? Normally, are you going to turn it into a list? No, you're going to use it inside a for loop. For x in range, 1, comma 10, print x, and it prints 1 to 9. Or, since I have that L variable already defined, I could do for x in L colon, print x, and it's going to do the same thing, right? We saw this in our code. It's going to step. Every value in that list is going to fill in the x variable in turn. And the reason we can do that is because we already stored that range inside a variable called L. So it's close enough, perhaps, to follow that slide and say that range returns a list. But actually it returns a sequence that you can convert to a list. Values in a sequence can be visited with a for loop. We just talked about that. For x in L, for Luke in whatever our list of colors was. The syntax can be made to look a little bit weird because you don't have to store the list ahead of time. I could do this. Switch up our variable. For y in, square brackets, and then I'm just going to put 3 words in here. Square, quote, Alice, end quote, comma, Betty, end quote, comma, Carol, end quote, square brace. And then since we're going to start indenting, we have to have a colon at the end. Print y. And it's going to print Alice, Betty, and Carol. All right, I never do it that way. I would rather store it in a variable and then iterate through the variable. I'd rather stick it in a list first. But that works. It's still a sequence of values. I'd just rather do this. I've never seen any production code, that somebody that does it that way, but it works. You don't have to do it that way. And just because I say that it's not common doesn't mean it is really not. If you look at this and it makes beautiful sense to you, great, do it that way.
Would there ever be a time that we can do a list like that in an if statement? I know that one of the homeworks, I'd already turned the homework in, but I was having trouble with that, trying to figure out how to use that kind of for in range with the if statement.
Remind me of what the homework was trying to do.
You had to, basically, if x was equal to 1, it would print out 1 through 10, or if it was equal to 2, it would print out 11 to 20, and then anything else was, I don't know what to do. So,
yeah, you would use an if statement followed by some for loops or while loops, right? Like you could do x, x equals input, whatever. I'm going to not actually do that because I don't like having to type in something, everything, but I'm going to call it choice. So like choice is equal to 1. Then I would do if choice equals 1, colon, and then I would use my for loop. For x in range 1, and if it was supposed to go up to 20,
yeah.
21, colon, parentheses x. That's done. Now I could come down here and do elif choice equals 2, colon, for x in range. We were supposed to count from 20 back down to 1.
Yeah.
20, comma, I'm going to go 1 past 1. The same way that when we're going up, we make it 21. I'm going to go 1 past 1 to 0, but I'm going to skip by -1 each time. Print x. And then finally, a dangling else, just to catch errors. Else colon, print, invalid choice. End quote. Like that. Is that close to how you did it?
That's close to how I ended up doing it, but it was frustrating.
Yeah,
It's
yeah,
like,
yeah.
how do I do this?
Yeah, yeah. That's how I would do it. You might be able to rig it so that you had one for loop and then you had choices inside it, but I wouldn't do it that way. I think that would actually make it harder. Did it not print 20 down to 1? Did I make a mistake?
You made choice equal ones.
Oh, yeah, right. I hard-coded choice to 1, so it's obviously not going to do the other.
Yeah,
Yeah.
I think the homework had to have the user put it in.
Right, right. And I'm skipping that because I don't want us to have to type that each time.
Yeah.
Good question, and I just gave you all the answer to the homework.
I'm sorry.
Quick, erase it! No, I'm kidding.
It's just, I was so confused at how to use the list, a for loop with an if loop.
Right.
They weren't working.
Right.
Along as.
Yeah. So you would use what we've done is we've so-called nested a loop inside of an if structure. So, which is fine to do. But, this is the kind of the outer sentry, the outer blocks of the castle, the gateways. We have these sentries, 1, 2, and else. And then inside the rooms, we have a loop that's doing something. So formatting text for output. We've done this a couple of times. Whoops, where'd it go? Oh,
We talked about that last time.
we've used printf
Yeah,
to line things up in tabs. Yeah. I forgot to mention that if you stick no I didn't, but I skipped a slide. If you stick a third number on your range, that's how much it adds, right? So if you put a 1 here, then the next time it's going to equal a 4. And then if the limit wasn't set to 6, it would print out a 7, a 10, a 13, and so on. So if you need to count up by tens, if you're going to count from, 100 to 1,000 by 100s, for x in range starting at 100, going up to 1,001, right, because you've got to go one past where you're going, and then each time add 100 to it. That would print out. I don't know why I didn't actually type that in our code. But anyways, hopefully you see what that's doing. We may as well go and do that. For x in range, parentheses, starting at 100, ending at 1,001, so it'll actually stop at 1,000, and go up each time by 100. Print parentheses x. There's nothing about magic about x. This could have been called ABC as long as that was as well. So if you're going to print in tabular format, you're going to wind up either using /t to separate things, but that's kind of lame. You should use formatted print statements. Quickie example just because we're here. For x in range, let's do that. 100, 1001, 100, colon. And then we're going to print out x to the power of 2, and then x to the power of 3. Now it's not going to be lined up. It's going to look lame. In fact, it's not going to work at all. Oh, I forgot something important. What did I forget? Yep, I forgot the word in there. So make sure you fix that line to have the word in it. All right, lame. What's our largest data value? How many spaces should it occupy? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So I'm going to format it so that, and since these are whole numbers, I'm going to use %d. For some reason, %d means whole numbers and %f means floating point. You'd think it'd be %i for integers. Okay, so after the print, or tell you what, undo that. Go ahead and put your closing parentheses at the end of it just so you don't forget it. But then at the beginning of it, put an open parentheses and a quote. and a percent 10d space percent 10d space percent 10d, end quote. And this looks different than what your Java and C guys are used to. Don't put a comma there, put the percent sign there. And now to print it in a table format. Each column will be padded out to 10 spaces to make everything line up pretty. If you don't give it enough room, like if you said, and don't make this change, I want each one of these to occupy 7 spaces, it's going to mess up. It's not going to look good. Because that number is the minimum number of spaces. Oh, make a liar out of me. It looks pretty good, but it wouldn't necessarily have looked good. What if we lowered that even lower? Percent 4D. And like I said, don't make these changes because I'm going to change it back to 10. Just a minute. Right. Now it's not looking good. Why? Because that's a minimum number of spaces. If the data exceeds that 4 spaces, too bad. It doesn't know what to do. It's not going to chop numbers off. So that number there between the percent sign and the data type inside your placeholder, that better be wide enough to hold your largest piece of data. If you don't care about how many spaces wide it's going to be, you just leave the number off. I could change that to percent %D, percent %D, percent %D, and it would look identical to how it was the first time I wrote it before I added the placeholders. So we're going to calculate the so-called factorial. If you calculate factorial of 10, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But I better declare an accumulator variable before I get into the loop. So total, fact, total is equal to, and my urge would be to make it 0. But I know better, because if you do 0 times 1 times 2 times 3, again, you can multiply it by me and it would still equal 0. So I wanted it to go from 1 to 10. For x in range, what should my first number be? 1. Not 0, because I wanted to start 1 times 2 times 3. And then what's the last number going to be? 11. And I'm going to count up by 1s, but if I leave that off, it does by 1s anyways. And then I'm going to do total times equals x. Multiply our current total by x. And I'm going to make a comment that this is a factorial. We may as well print it out. Print, parentheses, quote, factorial of 10 is, end quote, comma, total, end parentheses. I trust that that's correct. Guess I could Google it. Factorial of 10. Looks good. 362 whatevers. A summation loop looks exactly the same, except you initialize it to 0, and instead of multiplying it, you add it. I could cheat and just copy all that and make those 2 changes. I better change my comment because we're doing summation now. Total plus equals x rather than times equals x, and then I'm going to change that to summation. And that is correct. I happen to have that one memorized. Summation of 10 is in fact 55. All right, we're going to jump ahead to a topic mentioned later in the PowerPoint, which is random numbers. Why? Because random numbers are fun. You can't predict in advance what they're going to be unless you know their starting point, and we don't know their starting point in this language. We could specify a starting point, and then it would follow a predictable sequence that was the same every time. It's what's known as a pseudo-random number. What it does is it takes the last random number generated, runs it through a mathematical formula to pick another one. And in our eyes, it looks random. And if that last number starts off with something like the number of seconds since midnight or whatever, then it looks like it's a random sequence, because we're not going to run this program once a day at exactly 12 seconds after midnight or something like that. To get random to work, we have to import a library. Import random. Let me make sure I get this right. Yeah, okay. So that's slide 39. All right, x equals rand int. I want a number between 10 and 20. Notice that this is not like the range. The upper value of the range is inclusive, not exclusive. So sometimes we will actually get 20. Print parentheses x. Oh, and it blew up. That's because I forgot to precede this with the name of the library. I typed randint, but it needs to be random.randint. My mistake. Make sure you add that there. Right. That time it did a 13, but if we run it again, it's probably going to be something else.
Got an 18.
Yeah, 15. Each time you run it, it ought to be something different. 12. And sometimes yours is going to be the same as mine, sometimes not. 10. So, if you're playing Yahtzee or Monopoly or Risk or something, you roll cubical dice, which are 1 through 6. So let's have it roll 2 dice, 2 6-sided dice, and check to see if they're the same number. D1 equals random dot randint parentheses 1 comma 6 in parentheses colon. We better, whoops, where'd that colon come from? It's not an if or a while or a for. Backspace, remove the colon, and then just make D2 equal to the same thing. If you just even want to copy and paste it, you can do that. Except make it D2. Now we have 2 different dice to compare. If D1 equals D2 colon, well, why don't we print them out? We don't know what they are yet. So print parentheses quote D1 equals %D comma D2 equals %D end quote. And now the syntax gets fancy because it's a formatted print. So % open parentheses, 2 close parentheses, and then inside here, inside that inner pair of parentheses, D1 comma D2. Yeah, that was dumb. Thank you. That's why some companies actually pay to have 2 people per computer looking at the typing. That would drive me absolutely up the wall. But as you can see, make mistakes, fix it. Okay, so D1 equaled 5, D2 equals 6. Why don't we write a counter that will check, like if we roll this 100 times, how many times will those dice equal? And I actually have no idea about that. I know the answer to the other problem I'm thinking, which is how many times you'd roll a 12 or a 2, but I don't know that answer. So this needs to be in a counter. It needs to be in a loop, which means from here to here, we're going to need to tab that over. So highlight all that stuff from here to here, tab it. You can do Format, Indent Region, or you can just hit the Tab key, which is easier. And how many times are we going to do it? 4 x in range 1 comma 101, or I could have done 0 comma 100 colon. We need some kind of counter that's going to increment each time we find a match. So, again, that's some kind of accumulator. So above the for loop, I'm going to do match equals 0. At first, we don't have any matches. But in here, we're going to have an if loop, an if statement, which says if D1 equals D2, then we do have a match. If, parentheses, D1 equals D2, I didn't need the parentheses, sorry, that's another language. It works, but that's okay. If D1 is equal to D2, then why don't we print a message? Quote, they match, exclamation point, in quote, in parentheses, and then add one to match. Now I'm going to add a couple of comments. I'm just going to add an end if, and then I'm going to back tab and add an end for. Pound sign end if, pound sign end for. Why do I have an error on my Ethernet connection? No internet access. Is that true? No, it's not. All right. Anyways. At least it's not telling me it's not a genuine version of Windows. Now let's print the percentage, which is this number of matches divided by 100. Now this is a magic number, right? We might want to change it so that it rolled it 1,000 times or 1,000,000 times. So I'm being kind of lame by not putting that as a variable. But let's calculate it. Percent equals the number of matches, match. Okay, this is going to look stupid. Divided by 100 times 100. Why am I doing that? Because that's how you create a percent. If this was just a 7, you know, I'd want to put a 6 here. Tell you what. Let's change that to a 20, 21. We're going to roll it 20 times. So I change that 101 to a 21, and I can come down here and I can divide it by 20. Because that's how you calculate a percentage. Is you do the total, the part divided by the total, and then you multiply it by 100. And let's print it out. Print, parentheses, quote, dice matched, end quote, comma, percent, comma, quote, and a percent symbol, again, end quote, in parentheses, like that. That should tell us, if we roll it 20 times, how many times they'll match. So they matched 5% of the time. I'm going to run it again. 30% of the time. 20% of the time. If I increase the number, it becomes much more precise. Like if I change this to 1,001 and I change this one to 1,000, it's going to generate a very precise value that's going to be about the same every time, except it's going to take a long time to calculate it. 18.5%. I trust that that's pretty close. If I run it a second time, it ought to equal about the same. Right? Because the more often you repeat something random, the closer to the average it gets. All right, that took too long. I'm going to lower it back to 21 up here and 20 here. So if you're going to generate a random number, you have to do that. Import random. In fact, I'm going to add a few comments. to generate random numbers, import random, then use randint or random.randint x comma y, where x is the lower range, y is the upper inclusive. So that could be fun. If you played D&D or Pathfinder or whatever, you might want to roll up something that'll, generate your D&D attribute scores. Or if you're writing a game where two people are swinging swords at each other and they only have a 20% chance of hitting, then you could use random numbers for that. Or if each attack generates a random amount, of damage, then you can do that. For statistical analysis, sometimes you don't want to do it on a fixed sequence. Sometimes you want to do it on random sequences. And what slide was that on? I'm going to even put a reference to the slide that it was on. Page 39. All right. So back up here. Page 39 of PowerPoint. All right, I guess while I'm thinking about it, we should pick a date for the first exam. No, I don't want an exam. Don't worry, the exam's not going to be killer. I wish we could have it in this class, but since we only meet once a week, it's a really bad idea to use up one of our class periods with an exam. So you're going to need to take it at the library or take it online or schedule time to stay after into my next class period. Now, if you all did that, there wouldn't be any room in that class for people, so there's going to be a limited number of seating. So you're going to need to pick a slot in advance. Yeah. So let's make a note of that. It's going to be over chapters 1, 2, and 3.
And then also I keep getting an error on the connection.
All right, I'll come there. Just while I'm thinking about it, I better note this. You'll need to take it at the library or at home. If you take it at home, you have to register with a site called ProctorU, and you're actually going to have a camera, and they're going to watch you take it.
It's very awkward because you can't see
Kind of
yourself.
awkward. Yeah. So I would take it at the library, honestly.
And it's $25 to take it at home.
Yeah. Costs money, but if everybody's here, I would expect you to want to take it at the library, honestly. Or you can schedule a slot in my next class, right, where I teach C++.
Are we only able to take it on the 26th?
No. It's going to be a range of,
Oh.
like from Wednesday up to Monday. It's going to be a large slot. So I guess I should rearrange that, right? I should say it'll be from 27th up to the 1st. I would text me so you can get a slot. Out of those two dates, you could take it on the 26th or you could take it the 28th. That's when I'm teaching the slot after this. If and if-else statements. I am pretty sure that we know what an if and an if-else is. We're not going to look at this slide for very long. However, we're going to look at this. If you want to compare two, you have to use two equal signs, not one. If you want to see if they're not equal, exclamation point equal, less than, greater than, less than or equal to, and greater than or equal to. There's this minor point. Well, it's not minor, but I need to mention this. The opposite of x less than y is not x greater than y. Because what if x equals y? Is x less than y? If they're the same? Is x greater than y? No. So, if you want to take the opposite of something, you have to do x greater than or equal to y to include it. Or you could just do if not x less than y. The not reverses the truthiness of it, but I want you to have that in mind. So opposites. Equal, equal, the opposite is not equal. Less than, the opposite is greater than or equal to. The opposite of greater than then would be less than or equal to. Again, this PowerPoint is lame because they're not indenting things. Like that. So enter the area. If the area is greater than 0, calculate the radius. I'm sure that that's right. Else, print the area must be a positive number. So if, else. You also have if, else. Or you can leave off the else altogether. If it's something or nothing, then you fill in the true block, but you don't even put an else. And if the else is not there, it's something or nothing. I'm going to slow down and stop here, but we're going to talk about the homework assignment. I don't know why I'm typing some of these notes in here and some of these. Guess I'll go back over here. So the homework has two sections, or really three. Section 1. Ask the user for x and y, and then calculate the sum of all digits between x and y inclusive. And let me just start this off with a triple quote so I stop seeing pretty colors that distract me. Example. Please enter x, and they type in a 1. Please enter y, they type in a 10, and I'm going to say sum of 1 through 10 is 55. Two, do the exact same thing, except calculate the product, which is multiplying, just like our factorial code. Factorial. So instead of printing out the sum of 1 through 10, right? Let's see if I remember the product, like of 1 times 2 times 3 times 4, or 2 to 4, right? So 2 times 3 is 6 times 4 is 24. So the sum of 2 through 4 is 24, if I got that right. And 3, write a loop that will generate pairs of random numbers, like our D1, D2s, between 1 and 6, counting the number of tries it takes for the sum of those numbers to equal 12. And I'm not going to even give an example of that. Well, I mean, I guess I could, right? We had some output over here where we where if I rolled it, if I ran it, it generated random numbers like that. And I'm going to fake it so that the last roll added up to 12. It took 5 turns. Maybe we better say which turn this is, right? Turn 1, like that. And then turn 2, so you're going to need a counter. Turn 3, turn 4, turn 5. I would use a while loop, not a for loop. You will need a counter. So you're going to start it off like at 1 or 0 and add 1 to each turn. I would break as soon as D1 plus D2 equals 12. There's more than one way to do it. Those are just my hints. If I was really mean, not mean, I'd ask you to write it so that you could pick which experiment you wanted to do, right? If you feel like doing it that way, that'd be awesome. I'll give you extra credit for it. If you don't, that's fine. You can just do one, one after the other, rather than asking them which one they want to do, and then do 1 if you enter a 1, do 2 if you enter a 2, do 3 if you enter a 3. Last 2 minutes, I'm going to show you one more code snippet, which is asking the user for a value and then not letting them escape until they enter it. Something like this. While true, x equals, are we going to do ints or floats? Don't really matter. Float, parentheses, input, parentheses, quote, enter a number between 1 and 6, end quote, end parentheses, in parentheses, because we had 2 opening parentheses. If the number is correct, we're going to break. If the number is not correct, we're going to display an error message. So if x is greater than or equal to 1 and x is less than or equal to 6, I don't recall if we've used and. Have we used and yet? Thumbs up if we've used and. Okay. If those 2 things are true, then we've got our value. We've got a good value for x. Else, colon, we're going to print an error message. Print number was not between 1 and 6. Parentheses, excuse me, in colon. So, I'm pretty sure that we also did this in the form with a try and an except. Try and accept would capture it even if they typed in some garbage value, right? Like an A or a B or something like that. I'm going to leave that alone now. I just want you to have that tucked in your brain. At this point in the programming course, once you master that, you ought to not allow the user to enter invalid numeric input. If there's a specific value that you're looking for, enter a value between 1 and 10, then don't let them type in a 0 or 11. Loop and catch the error. Now this one doesn't require anything like that, except you could argue that y has to be greater than x, right? Because if you're counting from 2 to 4, I guess if they made it x less than y, you can make it count down, right? But I'm not asking you to do that. You don't have to add error handling. If you feel like adding error handling, go for it. Let's put a note as to what this example is and then test it. This code test to make sure they're valid is input. Wait, the input is valid. It breaks when the input is good. It would not be hard to turn that into a try except block, but I don't want to confuse the issue. I want to focus on that. There's more than one way to write this. You could use what's known as a priming read. I don't like priming reads. I've already mentioned that. Alrighty. I think somebody said they needed help, and I think I blew you off, and I apologize. Let me make the Dropbox, and then I'll come back and help you. I apologize for not helping at that point. By the way, since I've had the family member having such major health problems, I haven't been counting anybody late for your homework. Hopefully you'll grant me the same forbearance because I've been late in grading your stuff. That's why, So don't get too mad at me. I'm trying to get everything caught up now.
Well, I think it's understandable, family.
Well, family's important, but y'all are important too, so I appreciate you saying that. Alrighty, there's a Dropbox F.